The Pew Research Center claims that 94% of all adult Americans own a cell phone of some kind. Terrence wants to test if this is true. He randomly surveys 457 adults and finds that 422 of them own cell phones. Do you think Terrence should reject the Pew Research Center's claim? Why or why not? So this is a hypothesis test. We have a claim. The Pew Research Center claims that 94% of all adult Americans own a cell phone. Terrence is testing if this is true. He's surveyed 457 adults. So we have our sample data. We have our claim. The claim is about the population proportion. And the claim is that 94% of all adult Americans own a cell phone. That's our hypothesis. 94% as a decimal is 0.94. So now, assuming the hypothesis is true, we need to identify the sampling distribution. Okay, so how does this work? Well, our hypothesis is that the population proportion is 0.94. So we are interested when we gather our sample in the sample proportion. That's the part of the sample that we're interested in, because that's the point estimate for the population proportion. How is the population or the sample proportion distributed? If we look at that sampling distribution. So if we look at the sampling distribution of population proportions, according to the central limit theorem, they are normally distributed. The mean of the distribution is the population proportion, and the standard error is the population proportion p times 1 minus p over the sample size, all under a square root. Okay, so in this case, we are assuming the hypothesis is true, so we are assuming the population proportion is 0.94. So 0.94 is our value for p. Square root of 0.94 times 1 minus 0.94 over our sample size. We have surveyed a total of 457 adults. That's a total number of adults that were surveyed. Okay, so let's calculate this standard error so we could get a better approximation here. So our p, our population proportion, is 0.94, which means our standard error, we take that p, we multiply it by 1 minus p, and we divide by our sample size, which is 457. And I think I'll throw that in here too. I like to have all of my numbers defined as variables. It makes it so that when I type it into the calculator, it looks a lot like the formulas that I use on paper. So p times 1 minus p divided by n. And then I take the square root of all of that. Okay, that's my standard error. 0.0111097. So that is my sampling distribution, or my standard error of my sampling distribution. 0.0111097. Okay, so let's use that and answer step 2. The sampling distribution is a normal distribution with a mean of 0.94 and a standard error of, and I'll just copy this number down, 0.0111097. Okay, so now that we have the distribution that we're going to be working with, step 3, find the probability. All right. So in this case, we first need to calculate our sample proportion. We want to know how likely it is that we get guess our sample proportion or something even worse than our sample proportion. So how do we calculate our sample proportion? Well, we know there are 457 adults that were surveyed. 422 of them own cell phones. Remember, the formula for a sample proportion is x over n, where x is the number of the members of the sample who have the characteristic, in this case have a cell phone, and n is the total members in the sample size. So 422 of the people who were surveyed own cell phones out of 457 total people that were surveyed. Okay, so let's calculate that. Our p hat, our sample proportion, is the 422 people that were surveyed divided by the 457 people total, which is also our n. So our sample proportion is 0.9234136. 0.9234136. Okay, which means, since this is less than our of the mean of our sampling distribution, which is 0.94, we want the probability that we get something as bad as our sampling as our sample proportion, or something even worse if we were to randomly select a sample. Okay, we want the probability that p hat is less than 0.9234136. That's our sample proportion that we actually got. Okay, so that's how we start this probability equality here. We're interested in p hat. That's the sample. That's the point estimate we're interested in that estimates our population parameter that we are hypothesizing about in step 1. We want less than or equal to. In the case of continuous probability density functions, they're the same. The difference of that single value doesn't actually make a difference for the probability. So I'm just going to use less than or equal to. Okay. And then I use the sample proportion I calculated, my p hat. Okay. Now what do I do with it? Well, I need to convert this probability into one in terms of a z-score, because the sampling distribution is a normal distribution. So we need to calculate the z-score. Okay. So we're going to go to a z-score. The inequality direction stays the same. And so all I need to do now is calculate the z-score associated with my sample proportion. Okay? So the z-score associated with my sample proportion is the particular value I'm interested in, my sample proportion, minus the mean of the distribution, which is the population proportion. That's the mean of the sampling distribution, divided by the standard deviation, or the standard error, which is square root of p times 1 minus p over n. And I have all these values in the calculator already, so I could just plug them in. My z-score is going to be my p hat, my sample proportion, minus p, the population proportion, which is the mean of the sampling distribution of sample proportions, and I divide by the standard error, which I've already calculated here, and I've stored it in variable SE. That's my z-score there. Okay, so I've got my z-score, and I know that in order to find this probability, it's the same as finding the probability that z is less than or equal to negative 1.49304. To find this probability, I just plug into my calculator. Again, this is a probability in the lower tail. And so if I want the probability of a standard normal distribution, I just plug in the quantile value, which is the z-score. So you could either type out negative 1.49304, or if you're like me, you could plug in just z if you've stored that z-score in variable z, if that's what you've named your z-score. Evaluate. The probability is 0.06771331. 0.6771331. Okay. That's step 3 done. Finally, step 4, we need to draw a conclusion. Okay? We know what we just calculated is that if the hypothesis that the population proportion is 0.94 is true, the probability that a random sample would have a sample proportion of 0.923 or less, so our actual sample proportion, or even worse, even further away from the hypothesis, is 0.0677. So that's about a 6.7% chance, 6.8% chance of that happening. Okay? Whoops, and I wrote it wrong here, didn't I? I forgot a 0. 0.0677131. There we go. Okay, so there's about a 6.8% chance that just by chance, if the hypothesis is true, that we get a random sample where the sample proportion is 0.9234 or even further away from the hypothesized population proportion of 0.94. Okay, so what do we conclude? Well, 6.8%, that's a pretty low chance, right? It's not crazy. This is where it kind of is up to us. Ultimately, when we conduct a hypothesis test, it is a choice at the end based on the probability. Do we reject the claim, or do we not feel we have enough evidence to reject the claim? And the choice will be based, problem to problem, will be based on the situation. We will learn later on in this chapter how to do this a little bit more deliberately. But right now, this is a choice. Okay? Now, we don't actually have to answer in your exercises. You just need to think about it. Do you feel that this is small enough that you could say, yeah, this is probably false? Or do you feel, well, you know, this may not be small enough to justify that? It is pretty small. Okay? 6.7, 6.8%, that's a small probability. But it's big enough that things like that happen pretty often. Okay, pretty often. It's not that crazy. So it's really up to us. Do we think that this is a low enough probability that we say, you know what, yeah, this is low enough that I am comfortable saying that this conclusion, this claim, is not true, that there really aren't 94% of all adult Americans own a cell phone? Or do we look at this and say, you know what, that's a low probability, but it's not low enough. I am not ready, I'm not comfortable yet saying that this hypothesis is false. The evidence is not strong enough to make that conclusion yet.